Alright guys, here is the practice quiz video for the 3-1 to 3-3 quiz. What I will say is that the real quiz is going to look a lot like this, guys. So make sure that you are working through this and perhaps copying some stuff down from the video if you need to. So first of all, to determine whether a relation is a function or not, we've got multiple things we got to think about. When it gives us a table, it's just a matter of not having a repeating x value, which actually is the same for points. So right here, I have a repeating x value, so the answer is no. You do not need to write y, but I'm going to tell you because a repeat x is why it's no. Versus here, 5, -3, 1, 3, and -1. 3 and -3 are not the same. 1 and -1 are not the same. I have no repeat x's, so no repeat x's, right? So the answer is yes. When the x's don't repeat, that means when I go to graph it, nothing is going to go through it for more than one point if we think about the vertical line test, which is really what we got to do for number 3, right? So is it a function or not? Well, does it pass the old vertical line test? And it does. Even at this point, it's only going through that point one time. So the answer is yes. And again, because of the vertical line test, it passes. Right? And that's going to be important when we talk about maybe something that is or is not a function later. For this, if you remember from this video from the first day of the section, this is -10,1, this is -8,1 because they're mapping onto those points. This is -6,2, this is -4,2 because again it's pointing all at those, right? And -2,2. And what you'll see is there is not a repeat x. And if there's not a repeat x, then it's yes, right? No repeat x. You do not need to tell me why when you take this quiz. I'm putting it here so you can see why. But really, it's just yes or no answers for all of these. Okay? All right. So, to create a table that's not a function, you must, move it down a little bit here, must have a repeat x value for it not to be a function, right? So I don't care what numbers you put in here, 2, 4, 6, 8, 10, doesn't really matter. Up here, I don't care what numbers you put in either, but you gotta have at least one x that's repeating. Look, it's just like this. We said this was not a function because it had a repeat x. So I'm just gonna put 2, 3, 4, 5, 2. If I put 3 here or 4 here or 5 here, any of those would be sufficient. If I wrote 2, 2, 2, 2, 2 all the way across the board, still the same thing. Now this is not a function again, because it has a repeat x value. Okay? For something that is a function, well, let's talk about something that's not a function first. This right here, not a function because it does not pass the vertical line test, because right here that vertical line goes through twice, that goes through twice, and so on. So really all we need here is something that passes the vertical line test, right? Something that I graph that passes the vertical line test. So it can be any kind of like a line, or it could be like a parabola that passes the vertical line test, but it can't be a sideways parabola because then it would kind of look like this, right? So I only need you to draw one thing in here. This is something that passes a straight line, is always a function. A parabola is always a function. I could have drawn any directional line, but again, and I could even do something like that. That would still pass the vertical line test. But I can't have something like this, right? Okay, so moving along for number 7. 8 and 9. First, let's just say, is it a function or not? This is just yes or no. This passes the vertical line test, so yes. This passes the vertical line test, so yes. This does not pass the vertical line test, so no. Okay, that's a good place to start. The second place I think is kind of the easiest, next easiest thing is it linear or nonlinear? Which means, is it a line or is it not a line? This is a straight line, so linear, right? This, if you connect the dots, would form a straight line. So it is also linear. This is two lines connected together. That is nonlinear. Okay. All right, so let's go at this in terms of domain and range. Let's go at this from easiest to hardest. This, if we identify all these points, this is -2, 2. This is -1, 1. This is 0, 0. And this is 1, -1. The domain is just the x values. Matter of fact, I'm going to write that next to the domain for all these. And the range is just the y values. So what x values do you have here? Look, -2, -1, 0, and 1. It's the first values in each of these points. -2, -1, 0, and 1. That's my domain. My range, I'm going to go in order from this way. I could write 2, 1, 0, -1, but it's all the y values. And the y values in order are -1, 0, 1, and 2. I don't care what order you put them in, but that's how that works. Okay, so for points, just identify the points and write the x's in the domain and write the y's under the range. It kind of works that way for this point too. If you can identify the endpoints, this is the point 2, 2. This is the point -4, 0. If you remember in the video, I said you could draw a box around these, and that goes from -4 to 2, right? Which you can see from our points. So the domain goes from -4 to 2, and what you're just going to have to memorize is that domain is x, so we put it in between our two values. And what is the y going from? Our y is going from here to here, so it's going from 0 to 2. And again, you can see that in your points from 0 to 2. And then for the range, we just put a y in between and less than or equal to signs, right? Because it's all the values of y between 0 and 2. Why is that not the case here? Because they're simple dots. They're not connected. These are connected, okay? That's it for that. For this last one, okay, what we see here is, again, if I try and draw a box around it, I can't really draw a box around arrows. I can't do that. But I can see that nothing is over here for this graph. So for the x values, they are from 0 or 1 or 2. They are all the values that are greater than or equal to 0. They're all, even if you just wrote positive values here, I would be okay with that. Okay. The range, well, this keeps going up in the y and it keeps going down in the y. So the range is all real numbers, or you'd put all real numbers. Okay. And that's it for that. Again, your quiz is going to look a lot like this on this page. Okay. All right. Let's look at kind of one more that I just want to throw at you. What if I give you like a straight line? Like if the graph looks like this and I give you this, right? This is at -3. And is that a function? Well, yes, that would be a function because I can go through it, so that would be a yes. What's the domain? The domain is the x values, and it keeps going in both directions for x, so the domain would be all real numbers. The range is only at -3 no matter what I go on here. The y value is always -3, so I would just put y equals -3. And is it linear? Well, it's a straight line, so linear. Linear. Just showing you another example because you might see something like that on the quiz. Okay? Let's flip it over to the other side. Okay? So for the first one, find the change between the x and y values to determine whether the function is linear or nonlinear. So if you remember, what I said is if you do the change in y's, 1, 1, 1, and it's consistent, then it's linear. This is 2, 2, 2, and 2. So if I do the change in y over the change in x, I get 1 over 2 for every single one of these points. So yes, it is linear, right? Maybe even I just write linear, right? Either one. This one is going up by 3, 2, 2, and 2. It's okay if they're inconsistent, but they have to be consistent across the board when I divide them. 2, 2, 2, and 2. So if I go 2 divided by 3, then I go 2 divided by 2. Those are not equal. So no, or non-linear. Okay, because it's not a consistent y over x. We've talked about that before. All right, for these, remember how this is just plug in those three values. So I'm going to have g of -2, g of 0, and g of 5. And I'm going to write them in those blanks. Okay, it's the same thing over here. I'm going to do f of -2, f of 0, and f of 5. And remember, the reason we do these is really to look for points on a graph. We'll see that down below. When I plug in -2, it's 3 times -2 plus 2, which is -4. When I plug in 0, it's 3 times 0 plus 2, which is 2. When I plug in 5, it's 3 times 5 plus 2. Sorry, I didn't need that parentheses there, which equals 17. Okay, and now what they get, to write them as ordered pairs, we're plugging in the x value. So for each one of these points, I could have right away put -2, 0, and 5 in the x column, because remember these points are x comma y for every one of these, right? What did I get when I plugged in -2? I got -4, that's what goes here. What did I get when I plugged in 0? I got 2, that's what goes in here. What did I get when I plugged in 5? I got 17, and that's my answer, ladies and gentlemen. Okay, on the next one, this is a -1 really, so -1 times -2 minus 5, -1 times 0 minus 5, and -1 times 5 minus 5. Right? Do I need a negative 1 there? No, but I do need a negative because then I see this is a 2 minus 5, which is negative 3, because a negative times a negative. 0 minus 5 is just negative 5. And this is negative 5 minus 5, which is negative 10. So I get, again, I get 3 points. I plugged in negative 2, 0, and 5. And I got negative 3, negative 5, and negative 10 as my solutions. Okay? And again, they are written as ordered pairs, which means they're written as a point. Okay? Why? Well, because we're going to go solve for problems like that down here. But first of all, and this one is different from the rest. It's basically saying g of x equals negative 8. So if I know what g of x is, I can replace it right there with negative 8 equals negative x minus 5. And then how do I solve that? Well, first of all, you got to get x by itself. So you got to get rid of this. What's the opposite of minus 5? Well, that would be to plus 5 to both sides. Right? So I get, write it up here, negative 3 equals negative x. And remember, a negative x really just means negative 1x. So when I divide both sides by negative 1, I get 3 to be x. And that's it. That's all you have to do for that one. It didn't ask you to write it as a point or anything. It just says find x. Okay? All right, for the next ones, you got to plug this in. Okay? Which is as simple as taking these 5 numbers and plugging them in right there. It's exactly what we did here. I'm not going to write it as fancy, but it's literally going negative 2 minus 3, negative 1 minus 3, 0 minus 3, 1 minus 3, and 2 minus 3. Again, I'm plugging each of those points in right there for x on this column, and then subtracting 3 because that's what the problem says. And use your calculator. You don't need to do this in your head. And those are the numbers that go here. Negative 5, negative 4, negative 3, negative 2, negative 1. I'm going to do the same thing over here, and then I'll talk about how we graph them. So, oh man, you couldn't even see that. Look, I'm going to try this one more time. Negative 2, negative 1, 0, 1, and 2 get plugged in right there for x. So I've got negative, all those written down here, and I just minus 3 each time because that's what it's asking me to do. So similarly over here, I'm going to plug all of these numbers in right there for x. So I'm going to have negative 2 times negative 2 plus 1. Negative 2 times negative 1 plus 1. Negative 2 times, you know, if you notice, it's really just plugging in to that parentheses for each of these points, 0, 1, and 2. And up here I get, let's see, negative 3, negative 1, 1. Oh man, I did that wrong. A negative times a negative is a positive 4 plus 1, which is 5. Whew. Good thing we caught that right here, right? Negative times a negative is positive 2 plus 1, which is 3. And this is still 1, and the reason I caught it is because negative 2 plus 1 is negative 2. Don't try and do this in your head. You even see me make a mistake. Don't try and do it yourself. Ugh, negative 1. Okay, so use a calculator when you're plugging this stuff in. I'm just trying to prove a point there, or maybe I just made a mistake. So those are the numbers 5, 3, 1, negative 3 that go in there. And now I just plot my points, right? So this point, negative 2, negative 5 means negative 2 in the x, negative 5 in the y, right there. Negative 4, negative 1 means negative 1 in the x, negative 4 in the y. Now these should form a line, right? 0, negative 3 is over 0 and down 3. 1 in the x, 2 in the y. And 2 in the x, 1 in the y gives me those points. Connect my dots. That's my line. Okay? Same thing over here. Right? I got all these points. So negative 2 in the x, 5 in the y puts me up here. Negative 1, 3 puts me right there. 0, 1. 1, negative 1, and 2, negative 3 down here, right? So boom. Creates my line there. And again, they should all be on that line, or you might have done something wrong with your math, okay? That's it. That's what the quiz looks like, y'all. Study this. Maybe you watch this video one more time, because again, the quiz is going to look almost exactly the same. 16 problems. They're all laid out in the same place. Have a good one.